And so what I want to talk about is some grading stuff. And this is really on a day-to-day basis, this is going to be the stuff that is most important for grading. So the first thing is this, and this is, we went through this the other day, so I'm not going to go through this again. When we have an assignment in class, why is this happening? When we have an assignment in class, I don't want that at all, but I don't know how to fix it. Okay, when we have an assignment in class, I'm going to give you points just for working hard, and I'm going to give you those points based on you turning in something. And if you get whatever it is that we're doing done, great. If you don't, but you were working hard, that's great too. Your score in class is going to be based entirely on effort, all right? And that is going to give you some points. In fact, it's going to give you enough points that you can't get an A unless you're getting mostly 3s with the occasional 2 on the in-class work. So if you're not getting mostly 3s on these assignments, that's your indication. It has nothing to do with whether you know physics. It has nothing to do with whether you can do the work. It's just, are you showing the kind of effort that you need to show in order to get an A or a B or whatever it is that you want to get? Okay, and this is my evaluation of your work based on what I see in class, not just what you turn in. So you could turn in something perfect, and that would be great. But if you didn't do anything, then I'm going to give you a 1 because that's not effort, right? Like that's having something done already. We'll talk more about that in a little bit. What I want to talk about next is the work that is done that shows me so that I can tell you what you've learned, all right? And the way this class is going to be structured is everything that we do is going to be targeted at a skill. So it's not just a matter of, did you get the right answer? Did you make the graph? Did you turn in something that's legible? It's, can you do this? So for example, one of the skills that we started on Tuesday and we're going to continue today is, can you interpret a velocity versus time graph? You can't see this one, and that's okay. We'll talk about this later in the class, but there's a graph up here. And there's some stuff written on it. And one of the words says moving, and one of it says back to where you started. And that was a student who did that. I drew the graph, and then the student said, well, you're moving here and you're back to where you started here. And the thing is, that's not right. This is a velocity versus time graph. It doesn't show where you are. And so one of the skills is, well, when you're looking at a velocity versus time graph, you have to be able to recognize that the information on that graph directly tells you an object's speed in the direction of its motion, not where it is. You know nothing about where it is directly. Another skill that we're going to be working on is that indirectly, from a velocity versus time graph, if we know how fast something is going, we can often figure out where it is as well. So we're going to do both of those things from this graph, but directly, we don't look at this graph and see location. We see how fast something is going and what direction it's moving. And that's a little tricky for many people. That's a skill. It's not a skill that I can evaluate by looking at a piece of paper that has the correct answer on it. It's a skill that I intend to evaluate by actually watching you. I'm going to watch what you do in class, and I'm going to evaluate your ability to do the work. As we do this work, every single day, I'm going to be working with you individually, many of you one-on-one and some of you in small groups. And if I get an idea of what you can do, I'm going to give you a score on that. The score is going to show up in Canvas. It's going to be visible by you and guardians, but it's not going to contribute to your final grade. Not yet. Which means that as we work over the course of 2 or 3 weeks on sort of a big topic with a set of skills that are identified with that topic, you will know how you're doing, because I'm going to be telling you. Every single time I interact with you, I'm going to be able to get some information about what you are able to do. And as I accumulate that information, I will put it into Canvas so that you can see it. This is stuff that we need to see. So it's not going to work if you give me something, but I didn't see you actually do the skill. And we'll talk more about that later, because this is a really common hang up for physics students, and I'm kind of revamping the way that I do this year because I want to address it. It's been a problem in the past. I want to address it this year in a way that works for you. And ideally it'll work for me too, but the most important thing is that it works for you. And so the way you're going to get scored on these skills is with a 0 to 5 score. And remember, this isn't going to count towards your overall grade. This is just feedback. It's just how well you can do this. And I'm not going to go through all the numbers because it's going to be pretty intuitive, but the closer you are to a 5, the closer you are to mastering the skill. You are showing me on a daily basis that you are working and you've mastered the skill if you get a 5. If you get a 4, you're working, but you haven't gotten there yet. If you have a 1 or a 2 or a 3, that is incorporating some of your work effort. And so if you're getting 1s and 2s and 3s, not only do I not see that you've mastered the skill, but I don't see you working the way that you need to get there. You're not gonna master the skill if this is how you're approaching it. So that's feedback for you about what I'm seeing in class. Super easy to get at least a 4, okay? Because if you are locked in, trying to learn stuff, you're already here. You're already at a 4. Because if you are working hard, you will be learning. It is impossible to apply yourself consistently and not learn anything. So if you are using your class time, working hard, learning what you need to learn, then you've already got a 4 because you're going to be learning the whole time. And I'm very satisfied with that. 4 isn't an A though. If you want to get an A, then you're going to have to move to this next level of demonstrating your ability to do the things that we're asking you to do. I'm going to give you a couple of examples of that today. But before we do that, I want to show you how this is going to connect to the scores that do count toward your grade. These won't. Every chunk of work that we do in this class, 2 to 3 week periods of time that I'll refer to as units, every chunk of work is going to be associated with a handful of skills. You'll see those skills in Canvas. Had Canvas been running last week, you would have seen those skills already. They would be in there already. A heading with a brief description of the skill and then some more detail so that you can see, oh, this is what I'm going to be expected to do. I'm going to be able to, find an object's location by using a position versus time graph. Estimate how far an object will have moved over a certain amount of time by using a velocity versus time graph. Those are the types of skills that you'll see on Canvas, and as you start accumulating evidence, you'll see numbers. Those won't affect your grade. Those skills are going to be assessed at the end of those 2 to 3 week periods of time. And the assessments are going to be in class, and the assessments are going to be skill-based. They're going to be lab-based. Those of you in AP Physics, there's an additional piece for you. Okay, you're going to have the lab-based skills. You're going to have an additional piece as well, and I'll tell you about that a little bit today, and we'll go into more detail next week. So for the summative scores, we're going to do something. In class, it's not going to be a sit-down test. It's going to be you are doing something. So for the motion graphs that we're looking at, it might be that you are given some information and told, make a position versus time graph. Sketch the position versus time graph that is created when you move like this. And you'll have time in class to do that. And as you work through the assessment, you'll have a chance to demonstrate all those skills that we were talking about. Now, here's where the formative work comes in. If you've already showed us that you got it, then we don't need to see it again. Okay, this is not the kind of thing where it's like, I watch you jump rope, and I watch you jump rope, and I watch you jump rope, and then I'm like, okay, I'm going to test you on your jump roping ability, and you trip. That kind of sucks, right? Because if you could jump rope on Monday, and you can jump rope on Tuesday, and you can jump rope on Wednesday, then if you trip on Thursday, that's not really a good measurement of whether or not you can jump rope. So I'm going to use those formative scores. I'm going to look at them. If you already nailed it, then you nailed it, and I will transfer your 5s right over. Okay, I'll transfer the other scores over too. unless you do better on the assessment. So if you got 5 on interpreting a position versus time graph, and you got a 5 on interpreting a velocity versus time graph, but in the formative work you got a 4 on making a velocity versus time graph from a position versus time graph, well then you've got another opportunity to bring that up to a 5. It'll stay at a 4, it won't go down, but it could go up to a 5 too, which might be kind of nice. This again is something that we need to see. We'll give you time in class. Some of you won't be here. Some of you will have missed some of the formative stuff. There will be no evidence for one or more of those skills. And then we have an assessment. You're not there for that either because you have a doctor's appointment. And so what I will tell you is, we'll talk more about this next week. For today, all I will tell you is that's fixable. It's just that we still have to see it. I can't evaluate your skill in doing something if I don't watch you do it. So I have to see it, and there's lots of different ways that we can make that happen. I just mentioned this, I'll say it again, and then we'll talk more about this next week. But if you're in AP Physics, there is also going to be a paper and pencil test. It's going to be looking at the same skills, same stuff, but it's going to look the way it'll look on the AP exam. The AP exam is skill-based. It's just that it has to be sort of like, how would you do this in a lab environment? So the AP exam is basically set up so that you're doing a bunch of lab work, only instead of taking a motion sensor and setting it up and walking, it's telling you, suppose you have a motion sensor and it's set up and hooked to a computer. You create a velocity versus time graph that looks like this, and then it'll ask you a question about that velocity versus time graph. So it's all the same skills, just without the equipment, okay? These traditional tests will be about like half of the summative stuff. So basically it's going to be about a 20-80 split. 20% is going to come from the in-class work, those 3-point assignments. 80% about will come from assessments. And so in AP Physics, about 40% of that is going to come from these summative scores. The other 40% will come from a test, like a regular old-fashioned test that's on paper and pencil that you have to do by yourself and get things right, okay? In AP Physics, we'll talk more about that next week. You'll hear what AP Physics is going to be like. You'll hear what's going to be different about AP Physics from regular physics. You'll hear what the tests are going to look like. If you are in AP Physics and want to stay there, then you should be part of that conversation. If you're considering joining AP Physics or dropping AP Physics, you should still be there for this conversation. So if you're thinking, well, maybe I will take AP Physics, you could do that. Just let's talk about it next week and you'll have an idea of what it's going to look like. It's not beyond anybody's ability, certainly not beyond anybody's ability. Conceptually, the work is the same. The difference is what you have to do outside of class to master the techniques to get these kinds of problems right. Our tests in this class are going to be aimed at giving AP students the skills that they need to do well on the AP test. That's the only difference. Regular physics is physics. AP Physics is physics plus advanced test-taking skills. That's it. The grades are going to look the same. The effort is gone because at this point, like, you either put the effort in or you didn't, but I'm going to assess your ability to complete the task and your understanding. And again, what I'm hoping, like my big hope for this is to accomplish 2 things. One is to communicate to you before your grades drop what I've seen. If you're getting a bunch of 4s and 5s on those formative scores, then you can be super confident. Because not only do you know that you know the material, but you know those scores are going to just roll right over into the ones that can. You'll see it coming, all right? And you'll also know where you need some work. If you have a 2 or a 3 in there and you're like, okay, well, I guess I don't know this yet, you'll have time to figure it out, and then you'll have an additional chance to demonstrate that on the final assessment. And my hope is that what this creates is an environment where people are willing to challenge themselves and ask questions and learn. An environment where there's no surprises. You already know what your grade is likely to be on the assessment. It's only going to be higher than what you got on the formative part. I'm still gonna ask you, even if you have all fives, I'm still gonna ask you to do that final assessment, that final lab. That's gonna be the big evidence that I'm able to provide to anybody who asks. This is the evidence that I have that the student can do the skill. And this is gonna be an opportunity, if you are maxed out in your formative stuff, the pressure's off. You can just actually have fun. And that might be a challenge for some of you because might be a new thing for you to actually enjoy an assessment. But if you have any interest in a career in science or technology, engineering, anything like that, my gosh, that's where the fun is, right? Like if you end up going into structural engineering, the fun part is when you design a bridge for somebody and you get to see it take shape. Is that an assessment? You better believe it. If you mess up when you're designing a bridge, you're toast. Your career is over. And you're likely to it's gonna impact the rest of your life. Like that is a disaster. Does it happen? Well, yeah, it does. But for the most part, the people who are out there as structural engineers, they're doing what they love. So when they're designing a bridge, they're not thinking, oh, I gotta get this right, or I'm gonna get a bad grade, or I'm not gonna get full points. They're thinking, I know I can get this right. I know what I'm doing, and I have a team of people that I'm working with that are gonna help me. And it's fun to design bridges. And that's what I'd like you all to do when we have the final assessment for like this motion graph stuff. I'd like you to be thinking, okay, cool, this is kind of a cool little challenge. I know I can do this. I know I already aced it. I got my grade. And also, like I'm gonna do it again. And I'm gonna nail it, because it's fun. And if I don't nail it, then I'm gonna work with my classmates and with Brigard to figure out what went wrong, because it's fun. It's really fun to figure out like, ooh, this isn't working, how do I fix it? That's what physics should feel like. I think that's what all learning should feel like, all right? I'm gonna just talk about one more thing really quickly, which is sort of an analogy to kind of, like, I would like to make my case for skill-based assessments instead of answer-based assessments. And I would like to just clarify why I'm doing this, why I feel the need to have a system that's a little bit different from anything I've done in the past, and almost certainly different from what you've seen in your other classes. Before I do that, I just want to say that next week, one of the things that we're going to talk about is late work and reassessments and what happens if you miss like 2 weeks of school. And the short version of that is, if you are locked in while you're here, then I can work with you. This is not gonna be the kind of thing where you've got this many chances and then you're done, No, so I'm really sorry that you got in an accident on the way to school, you missed the assessment, and now you're toast. I will work with you to make sure that this kind of stuff gets taken care of when you are showing me that you wanna learn. And there's some systems for that, we'll talk about it, but you don't, just right now, I don't want you to panic about it, I don't want you to think. So that means even at the end of the summative assessment, if you end up with a bunch of 4s and you want a bunch of 5s, there is a path to that, okay? It's not gonna just be, okay, now where's my 5? Can I get my 5 now? It's gonna be you demonstrating these skills. You have to convince me that you understand how to do the things that we're talking about, but there will be a pathway for that. We'll talk about that next week. The last thing I want to talk about right now is an analogy, and this is like, I could come up with any number. Originally I was thinking changing your oil, but I don't know how to change oil, so I changed it to lasagna, because I can make lasagna. So let's suppose that this were a cooking class instead of a physics class. And I said, our goal is to learn how to make lasagna. What does that look like? Well, if your goal is to learn how to do something, it's really different than if your goal is to produce something awesome. Those are two different things, right? So to make a lasagna, most of you have done this, right? So this is gonna be obvious stuff, although for some of you, you maybe never have done this before. But basically you figure out what you're gonna need. You look at a book or you look online and you get a recipe. And then you gotta buy some stuff that if you don't already have it at home in your fridge or your pantry. Then you have to do the work. You chop up the onions and you saute the garlic, and my mouth is watering, and you like mix up you boil the noodles and you do all that stuff, and then you put it in the tray and then you bake it. And here's what's interesting about learning how to make lasagna is you can do a really good job of all of these things, like all of them. Like you could be the best shopper ever. You can follow the recipe to a T. You can have like a beautiful list of ingredients written down, and your lasagna still might taste like crap. It might have been a bad recipe, or it might have been the brand of tomato paste that you used, or maybe you did something wrong and you like a little step like, oh, I guess that wasn't salt. Those kinds of things. Like those, if you're adding like garlic powder instead of salt, that's going to change the way that your lasagna tastes. And so, interestingly, when you're learning how to do something, how it turns out in the end is not nearly as important as these steps. This is what tells me that you know how to do it. You know who can make a really good tasting lasagna? Trader Joe's, right? Like if your goal is to have a good lasagna, and you don't care about being able to make it, then just go buy one from wherever. Trader Joe's, Pastini, like whatever. I don't care. Stouffer's. Like those are all perfectly good tasting lasagnas. And here is where all of this comes together, because what has happened in the past, in physics in particular, in all my classes to a certain degree, is I have had students confuse the process with the product, and it leads to really unfortunate outcomes, okay? And in the two cases, right, these are the extremes, but they're not uncommon, okay? Case one is we have a student who is just not really doing their job. They're not learning physics, they're not working very hard, they're not thinking, they're not trying, they don't really care about physics. They know how to get A's though. You know how you get A's? You get some good lasagna. That's what you need. So I have students who consistently, throughout an entire semester, are dropping the ball. They know it, and I know it, and there's a lot of communication about it, both in a group level and sometimes on an individual level, and then at the end of the semester, they come to me and they're like, here's my lasagna. And it's awful, because then I have to try to explain to them, well, that is a great lasagna, but like, I didn't see you make it. And they're like, well, I made it. Okay, but I didn't see you make it. My parents saw me make it. That's not the same. It's not the same. I want to see it. I want to see what you can do. If you can, like, come up with a great lasagna, that is impressive. That's impressive in its own right, but that's not what I'm looking for. I want to see this stuff. This is what I want to see. If your lasagna doesn't taste that great, I'm okay with that. I would rather have you learn how to make one, because then you can change your recipe and change your approach and buy a different brand of pasta sauce or whatever, and then you can fix that later. If all you know how to do is buy lasagna from Trader Joe's, then you don't know how to make one. You just know how to procure one from the store. And so that's one, and it's a very unfortunate outcome, because I have parents and students who email me and they're like, well, I don't understand why my son or daughter got a B or a C or a D or an F. They turned in the work, and they don't understand that this is what I'm looking for. So I'm hoping that this grading system is going to help with that. I'm hoping that by seeing throughout the year, oh, they don't have the skills yet. And then when we do the final assessments, since those assessments are in-class assessments, again, like if I don't see it, it doesn't count. This video that I'm making right now is going to go on Canvas. I'm going to ask you to review this stuff with your folks so that they understand as well that I'm looking for this, not this. If you come to me at the end of the semester or at the end of a unit or at the end of whenever, and you produce something that I didn't see you make, whether it's a lasagna or a lab report, I'm going to tell you, go watch the video. That's what I'm going to say. Just go watch the video, because that's the response. Not out of anger, but just out of like, I don't want to be in a situation where somebody is super disappointed that they don't pass physics or they don't get the grade that they want because I never saw them doing any of these things, okay? The flip side of that scenario, the other extreme, are the students who want A's. If you want A's, and many of you do, then what I want is I want for you to know what I'm looking for. This is what I'm looking for, right here. This, the process, the skills. And those are possible for you to get. Some of you are gonna find this extremely challenging because some of you haven't done this before. It's just not something you've done. It's always been like, well, I got the right answer. You asked, you want me to like find how fast the ball is coming out of the launcher. 3 meters per second. How can you mark me wrong for that? Here's my work. 15 divided by 5 equals 3. How can you mark me wrong? And the answer is, I didn't see you do it. Anybody can write 15 divided by 5 on a piece of paper. Anybody can put that into a calculator and get 3. Not everybody can film a ball being launched from a projectile launcher, take that video, import it into a video analysis program, put the scale on, put the units on, put the origin on, mark the location of the ball over time, break that into horizontal and vertical components, and tell me how fast that sucker was coming out of the launcher. Do you see what I mean? That's a skill, and you all can do it, but some of you have not done it before. You've not done stuff like that before because you haven't needed to. And now you will. If you want an A in the class, one of the things that some of you are going to have to get used to is the idea that learning these skills is not the same as being like a maestro, okay? This is more like, well, cooking, or art, or music, or ballet, or sports. It's not something that you practice for 5 days and then you do on the 6th day and you're the best ever, right? So my evaluations are going to be reasonable. I'm going to be looking for you to do things that I know you can do. I'm not going to be asking you to like Albert Einstein your way through a physics lab, right? I'm going to be asking you to do things that I absolutely know that you're able to do, and then we'll see where we get. Because I think if you all are willing to work with this system, I think your stress will plummet because you'll know. You don't have to worry. You don't have to cram for a test anymore. You don't have to cry because you got a lower score than you thought you were going to. And I'm not going to ask how many of you have cried about an exam score, but I know it's happened, right? It sucks. Nobody likes that. That never has to happen again. You'll know. Walking into the assessment, you'll already know what the floor is. It's just a matter of how high you want to go. Okay. I'm going to shut off the video so that you guys can roundly scold me. No, I'm just kidding. So that you can ask questions without showing up on the video. So hold tight.